In previous lessons, we learned that we can create constant variables, or in other words, how to qualify a variable as being constant. We also learned how to qualify pointers and references as const. Now we can actually also qualify member functions as const, and that's useful in the case where you do not want that member function to modify the state of an object. We will typically qualify getters as const. In this example, I have an entity class. It has a getMember function in the public section, and I qualify that getMember function as const. You want to do the function name, the parentheses, and then the const, and then you want to do the body following that, so the opening and closing curly brackets. That is in the case where you declare and define the function in the body of the class, but here we declare the member function in the body of the class, and we define it outside, so both the declaration and the definition will have the const keyword. In the declaration, it will be right before the statement terminator, the semicolon, and again in the definition, it will be between the parentheses and the opening curly bracket, which again starts the body of the function. So that is how we qualify the member function as const. Now how does this sort of work to prevent modification to the state of the object? Well, in previous videos we talked about the this pointer. So just as a recap here, for non-static member functions, the compiler passes the object's address to the function as a sort of hidden argument. This hidden argument, the object's address, is available from within the non-static member function as the this pointer. Now in a non-const qualified member function, the this pointer is a const pointer to that object, so entity in this case as an example. It doesn't necessarily show up in Visual Studio as a constant pointer. If you try and assign another address to that this pointer, then you'll get an error along the lines of this is not an L value, but basically you can treat it as a constant pointer. So in other words, you should not try and assign that pointer to point to something else. It doesn't really make sense. The this pointer is supposed to point to the current object. So if you try and assign some other address to that this pointer, then you'll get an error because it doesn't make sense for you to try and do that. That is why it is basically constant. But in a const qualified member function, the this pointer is a const pointer to a const entity. So not only can you not assign another address to the this pointer, which you should not try and do in the first place, but you can also not modify the state of the object that that pointer is pointing at. Here's a more specific example. Let's say again we use the GameStats class, and it has a member function called setLevel. Now I mentioned typically you would use const with getters and not setters, so I'm doing this purposely here because of course we're trying to change the state of the object using the setter here. Now in the lecture on the this pointer, I mentioned that you can use the this pointer, and in that way you can access the members of that current object, so the level member for example, and in this case all we are doing is we are assigning the level parameter to the level member, but because this function is qualified as const, this is going to give us an error. The reason again is because we have a constant pointer, so you cannot assign a different address to the pointer, right? So constant pointer to a constant GameStats, and that means we cannot, through accessing that object indirectly through the pointer, go and modify that object. Remember that you can also do mLevel, the assignment operator, and the level parameter. This is implied, so it basically works behind the scenes. So it doesn't matter if you use this or not, in either case you are going to get an error. We have something called the principle of least privilege, and the goal is to grant the bare minimum amount of privileges necessary for the object to perform its function. And of course, qualifying our member functions as const is one way of reducing privileges or ways for the object to get modified. We can reduce errors by qualifying member functions as const, and that's going to prevent unintended modifications to the state of an object. Okay, back in Visual Studio, I have the entity class again as an example. In the public section, I have the getMember function, returns an integer, and we have the member right here, which I initialized to 15 by default, just so it has some value initially. Here I have the definition of the getMember function, and that simply returns the member. And then in main, I instantiate entity. I create an entity called entity1, and I do console output entity1.getMember. Alright. We'll run that, and that should print out 15. Okay, now let's do something silly here. In the getMember function, I'm going to assign 55 to member. This should print out 55 now. But this is a getter. This can cause all sorts of problems. Let's say I have a setMember function. You set the member to some value later on in the program, and then you do getMember again. It's simply going to print out 55 again. So it's a simple example, but it can give you all sorts of headaches. And what it boils down to is with some member functions, especially getters, you want to prevent that function from modifying the state of the object, or in other words making any changes or assignments to the member variables. And we can do that using the const qualifier. So with the declaration and the definition, I add the const keyword. And now because I'm trying to assign 55 to that member right here, if I build and run, I'll get an error now. Member cannot be modified because it's being accessed through a const object. So with this statement, this is implied. We don't have to use this to access the member. But even if I do this and the pointer operator and then member, I'm still going to get an error. If I hover the mouse over this, you can see it is a pointer to an entity constant. And as I mentioned, when we see the const keyword, that means it is not modifiable, so we cannot modify that particular thing. In this case, we cannot modify the current object because that is the address that this stores. In main, we have entity1, and if we do entity1.getMember, then we cannot modify that entity1 object through this pointer. Now, if we remove that const qualifier, then of course this will work fine. Build and run again, and that prints out 55. Now with the const qualifier removed, if I hover over this pointer, you will see this is a pointer to an entity. But this is basically also a constant pointer to an entity in this case, because if you try and make changes to this, or in other words, assign a different address to this, you'll actually get an error. I'll just try and do this as an example. An assignment to this is an anachronism, and something like that. And if you build and run, you'll get left operand of that assignment operator must be an L value. So hopefully through this explanation and some of the previous lectures that we've done on this and L values and R values and such, you can see why not only qualifying member functions as const prevents modifications to that current object, or that is to instances of a class, but also sort of why it does that or how it works behind the scenes. So I hope you found this section interesting. Okay, for this example I've modified the entity class a bit. In the public section I have the getMember that is qualified as const. Then I also have a setMember function, and of course I have the member in the private section, which I just initialized to 15 here, so we don't need a constructor or anything like that. Trying to keep the example concise. Okay, we have getMember right here. Again, we have const. That is part of the signature of the function. You don't want it at the front here. You're not returning an integer constant. You want that to be part of the signature of the function. Then I have the setMember function that is going to assign member P to member1. For this example, I have a helper function as well called print. The formal parameter is a reference to an entity constant. So when we call this function, we simply want to create a reference to whatever object it is that we pass in this case an instance of the entity class. We don't want to copy the entire thing over. Again, it will use less memory if you use pointers or references, especially with objects that can have many members. Now in this case, entity only has one member, but still we sort of want to get used to working in this way. So all this print helper function does is it prints out, so it does console output entity p, which is that parameter dot getMember. Alright, in main I instantiate entity, so I have an object entity1, I use the print helper function, and I pass in entity1. That should simply print out 15. Okay, I'll make one slight change. I'll scroll up. The getMember function we have right here, I'll remove that. I'll make sure the getMember function is no longer const qualified, and if I scroll down to the print helper function now, you will see we get an error. I'll just build and run that, and you'll see we get an error. Okay, this is one of the reasons why I showed you how the this pointer is qualified earlier. Remember that the this pointer basically operates in the background to access members, and if the member function is not qualified as const, then the this pointer is a const pointer to an entity, meaning that we cannot change what the pointer points at, but we can modify the state of the object, or in other words do assignment in that function. Now the reference in the print function is const, so we should not try and modify the state of the object that it references. Basically, if an object is const qualified, right, you can declare an object as a constant, just like you can declare a constant variable. So if an object is const qualified, the this pointer will be qualified as a const pointer to const, and so to const entity in this instance, and that is why you get a conflict. Okay, hope that makes sense. Let's continue and I'll try and walk you through this. But the thing here is this reference is declared as const. Okay, this entity parameter is a reference to a constant entity. Basically, it's a constant reference. So even though the entity itself in main here is not declared as const, remember we pass in entity 1 into the print function, even though that is not const, this reference in here is const. And because the getMember function is no longer declared as or qualified as const, the error comes in here because there's no guarantee that we will not change any member, or in other words the state of the object, when we call this function anymore. But again, this reference here is const. So I can still go and, right, I could have done something like that. I'll just comment that line out. And let's do something else here. Okay, and as you can see, the getMember function now changes the state of that object, so the member changes to 55. But remember here in the print function, that reference is const. So we are not supposed to make changes to the state of the object using this reference. Okay, that's illegal, and that's why we are going to get that error. Now, of course, if I remove this const in the print function again, then that error will go away. Build and run that. So you can see the problem with this helper function now, and because we do not have a constant reference, that reference parameter can now be used to modify the state of the object, and that's why you typically declare those as const. But let's just go here and qualify getMember as const again, and now of course this is illegal. This will enforce the rule that we cannot modify the state of the instances of the entity class. Right, so we'll get an error. Okay, so I hope this illustrates why, firstly, you want to use const references. The reference basically is the same thing as entity1, it's not a copy. So you can sort of make indirect changes to that object now, and to avoid that you want to use a const reference instead. But of course you can use getMember functions in other places as we've seen before, not just in helper functions. And so you really want to make sure to qualify those member functions that you know you don't want to modify the state of the object. Qualify those to const. Okay, here is another example for you. In this case, I have a constant entity called entity2. I'll just do console output entity2.getMember, so this function works. Build and run, and that works fine. I'll just remove this here. Now what if we want to do setMember? Now if you try and do the setMember function on the entity, the constant entity, then of course you'll get an error. I haven't talked about const objects all that much, but it's the same thing for a struct. If you have a struct and you instantiate that, you have a constant instance of that struct, and you want to assign something to one of its members, or in other words change the state of that struct, again you'll get an error. And this is similar to declaring a variable as const, but in this case we are declaring a constant entity. So I've instantiated entity twice here. I have this entity1 and then I have a constant entity as well, entity2. Both of those use the getMember function. Now the interesting thing I want to show you is that you can overload the getMember function here. Const is part of the signature of the function. Okay, so one function is const qualified and the other is not. Okay, in this getMember function, I'm going to assign 100 to the member variable, and then in the const qualified getMember function, again that is now overloaded, all I do is I return that member. In what we have in main, we are going to print out entity1.getMember, entity2 which is const.getMember. And as you can see with the entity1 member, we modify the state of that object in the getMember function. Okay, so it does not use the const qualified version of that function. We overload that function because again const is part of the signature of the function, so you can use that to overload the function with. The const object is going to use the version of the function that is const qualified. So that is an interesting thing to note. Now we won't be using that all that much. I haven't used this myself all that much, and the getMember function may not be the best example of it, but I thought I'd put it in here as a bonus for you, because you never know, you might run into a situation where you find this handy. One final thing I want to show you is the mutable keyword. If you have some const qualified member function, and for some reason you still want to change a specific member variable in that const qualified member function, then you can mark it as mutable, which is a bit of a freaky but probably a suitable name. Mutable meaning modifiable. Okay, I'll scroll up, and let's say in this function for some reason we still want to modify member1. And now it's going to complain, expression must be a modifiable L value. So back in the class definition, I'm going to declare this member1 as mutable, and now that member variable is modifiable in functions that are const qualified or not. So you can see here this member function is const qualified again, it's overloaded as const qualified, but we can still make changes to member1. So it's a bit of a freaky thing to do. Build and run. Instead of printing out 115, we get 100 and then 55. And you might find that handy in some cases. I would recommend that you avoid doing it in this way. But again, I'm just showing you this stuff so that when you see it in other people's code that you know what it does. And also if you run into a specific situation, that you have the tools available to you to solve those problems. Okay, just a summary for you on what we just discussed. Before we move on to the next section, objects that are const can only call const qualified functions. Objects that are not const qualified can call const functions and non-const functions as well. Okay, for the final section I want to introduce const correctness. Basically the goal with this is to prevent inadvertent modifications to the state of an object by doing the following things. So you pass by reference to const. So previously I talked about constant references and such. It's actually read from right to left just like you do with pointers. So it's more correct to talk about a reference to const. But just for short I often use constant reference, even though it might not be 100% correct. Because you cannot change a reference anyway, so it basically stays const. If you try and change it to point to something else, that doesn't really work, you're just going to do assignment basically. But it can still be a reference to a const. Similarly, you want to pass by pointer to const or const pointer to const to again avoid modifications to whatever the object is that the pointer points at. Then you want to do pass by value. With pass by value, the function can change its local copy, but the copy is destroyed when the function returns. And so that doesn't change the state of the calling object. You want to qualify functions that must not modify the state of the calling object as const, as we've seen in this video. And you want to ensure const correctness from the beginning. From some of the examples, we've seen that if you add const later on, then that could have a snowball effect, resulting in debugging and recompilation to see if that works. And that'll waste development time, of course. So for example, you can qualify one function as const, and then when you compile it can get an error because some other function that you use is not qualified as const, and so on. So you want to try and be const correct right from the start. And a couple of benefits of being const correct is it prevents inadvertent modifications to the state of the calling object, as I mentioned. That's really the goal, and you can avoid errors when using const objects. That's also why I demoed using const objects in this video, and some of the problems that you can run into with that. And you can protect against accidental assignments. So here we have a const qualified function in the class entity. The function's name is getMember, and in the body of that function I have an if statement. So if member1, and here you'll notice we have the assignment operator and then 3, so we assign 3 to member1. Of course we use two assignment operators next to each other, so two equal signs for the comparison, and this is a very common mistake. So because we are trying to do assignment here in this if statement, and because the function is const qualified, we are going to get an error here. Okay, so in this way it will actually help us avoid certain bugs that can pop up later on. Okay, I hope you found this interesting, and I'll see you next time.